All right, I'm back. Here we go. Rational inequalities. So the same location on this worksheet. What I'm about to show you is so that you understand how to do this problem right here. Now, rational inequalities require the most work, and they do not have a clear pattern. Now, yes, they do, but once you think you have found a convincing pattern, something comes along and disrupts it. Okay, so the steps that I'm going to show you to solve them are not difficult, but they can be time-consuming. They can be time-consuming. Way to write. Super good grammar. Anyway, here we go. See this guy? It's similar but not the same. This one right here requires a little bit of work. This one's kind of beefy, and you might say, well, it doesn't look that big to me. Yeah, it's got some heat on that one. Now, it's not the worst inequality I've ever seen, but it's not this one. So let's start with something. I only have 3 examples, and then you should be able to do that problem number 20. But here's the deal with this. An absolute value inequality. You do not treat it like a proportion. You don't. If you do, you will end up getting it wrong. See, you can't just put a 1 here and then cross multiply, because one thing about an inequality is if you multiply by a negative, you have to change the direction of the symbol. And since you don't know what x is yet, you could be multiplying by a negative. So cross-multiplying is not the answer here. So let me get rid of those marks I put in there. But I do know one thing for sure. I am able to add or subtract to both sides of an inequality, and I don't have to worry about flipping the symbol. So here's how we do this. We get everything on one side and 0 on the other. So I'm going to take away the 2 from here, which means I'm going to take away the 2 from this stuff, right? So I end up with x plus 1 over x minus 3 minus 2 is less than 0. So here's the deal. I need to get a common denominator. And this is not hard. We've done this before. I got an x plus 3 over here. Well, I need an x minus 3. So I need an x minus 3. Okay, if I change the bottom, I got to change the top. So I know in the bottom of my fraction, I will have an x minus 3. That is totally true. But what's going to happen in the numerator here? Well, in the numerator, I have all this stuff minus this stuff. So what does that look like when we make it pretty? Well, it looks like this. X plus 1, and then the minus goes with the 2. So it's going to boom, boom. I'm going to get negative 2x plus 6. Don't make a sign error. And then if I put all that junk together, I get x minus 2x, that's a negative x. And then 1 and 6, that's a 7. That stuff is less than 0. So here we go. Here we go. This is doing a rational inequality. First things first, I have to get everything on one side, 0 on the other, and then here's where the easy part comes in. Set this equal to 0. What would you have to plug in for x in the top to get 0? Well, if this was a 7, then it'd be a negative 7 plus, so 7 is one of my critical values. So here's 7, and set this piece on the bottom equal to 0 in your head. What do you get? Oops, crud. Get rid of that. You get a 3. And just to give you perspective, on my number line, if that was 0, then 3 would be on this side. Open circle, not closed circle, open circle. And then the 7 would be an open circle. And just like with any other inequality we've done, we're going to end up breaking this number line into pieces. Now, here's the deal. you might say, hey, is this like an absolute value inequality, where this would be what you called an ini because it's pointing in towards this information? Don't be too quick to judge. Check them, because I tried to warn you. Just when you think you have a totally established pattern with rational stuff, you don't. Something comes along and ruins it, and you go, what? And the more you work with them, of course, you start to see the light. But guess what? They only want you to do this one question on the packet, problem number 20. So I have a feeling you'll be happy if you just know how to do 20. So let's do that. So here we go. I'm going to pick something from this region, which would be 0. That would be a good choice. And you know what? I'm not going to go plug it back into the original. I'm not. Here's a quick shortcut thing. If I put 0 in the top, I get negative nothing plus 7. Well, guess what? That would make the top positive. And if I put 0 in for x minus 3, that would make the bottom negative. A positive thing divided by a negative thing is a negative. And guess what? Negative stuff is less than 0. So this stuff over here is valid. This stuff is okay. Now, just to show you, over here, I'm going to get another okay statement. I'm going to pick the number 10. 10 is a nice big positive number on this side. So I'm going to go 10. If you were plugged into x, you would be a negative 10 plus 7. Well, guess what? That would make the entire top of this problem negative. I'm going to then divide it by, well, if I put a negative 10 here, I'd get negative 10 minus 3. That's a negative 13. Oh, wait a minute. I am wrong. See? I jumped the gun. I was thinking, oh, I'm totally going to get this part to work out. But guess what? A negative divided by a negative is a positive. And I know for sure positive stuff is not less than 0. So this stuff over here is not good. Well, heck, what about the stuff in the middle here? See, you do not want to jump the gun with a rational inequality. You never know. So let's think here. If I were to plug in, let's say, how about the number 5? 5 is between 3 and 7. So I'm going to say 5's a good choice. You know what? Let's try it. So if I plug in 5, once again, I'm going to say, what if this was a 5, right? So I get negative 5 plus 7, that's a positive. So I'd get a positive on the top. And if this was a negative 5 minus 3, that's a negative 8. I'd get a negative in the bottom. So a positive divided by a negative is a negative. So you say, hey, negative stuff is less than 0. So what is this funky looking answer? Well, here's the weird thing. The stuff over here did not work. The stuff over on the left side did work, and the stuff in the middle does work. So I have an answer that looks like this on the number line. It would be, here's the number 3, open circle. Here's the number 7, open circle. I'm just putting 0 here for reference. But it would be all of the stuff that is less than 3 and all the stuff between 3 and 7. But I would not include anything else. And remember, this guy right here is an open circle. You can't include that answer. And you might say to yourself, why? Why not? Well, think about it. If I put 3 here, then I'd have 3 minus 3 in the bottom, and I'd have 0 in the denominator, and we can never divide by 0. So the answer written on the number line, because remember, that's how they asked us to do it, that would be my result. If we were just in, just to let you see it, in interval notation, it would look like that. It would be all the stuff that is less than 3, but not including 3. That's why it's parenthesis, not including it. There is a gap because of that, because we don't include 3, but then we go all the way up to 7, but at 7, we don't go any farther either. So this would be, once again, this is sketched on a number line. And this guy right down here, this guy would be our answer in interval notation. Just so you know, that's what they would look like. All right, I got a couple more examples to get you there, because I wanted to try to warn you. Don't look for like a super pattern that's always going to work. Sometimes you see something and go, oh, they're all going to do that. And then something comes along and it's not. So let's move the 4 over. No matter what, when we do one of these, we start it the same way. We're going to move the 4. That would leave a 0 over here. And then I'd say, I need a common denominator. Hey, I need to be the denominator. So what we're doing to start this problem off is very similar to the other one. And then I could say to myself, hey, that negative's going to go with the 4. So in the bottom, what do I have? I have an x minus 5 in the bottom. But in the top, in this numerator, I'm going to have, here, let's change this thing to a yellow. We got this minus this. So what is that? It's 2x. Take away 4x plus 20. And then if I combine like terms, I would get negative 2x plus 20. And I can visualize what my critical value is going to be there. I can totally visualize what my critical value is. In the top, what would x have to be? Well, if I set the top equal to 20, equal to 0, I would get 10 as an answer. If x was 10, the top becomes 0. So I know one of my critical values is at 10. So I'm just going to say, here's 10. Here's 5. My bottom critical value is easy. I just go, oh, 5. Just for perspective, here's 0 on my number line. And then you might say to yourself, oh, I am going to take these circles and color them in or leave them open. And your brain says, oh, definitely color it in. Don't do it. Don't color it in. If you color it in, it means 5 is a valid answer. But here's the sneaky part about rational stuff. If I put 5 in the bottom, I will get 0 in the bottom, and I cannot divide by 0. So you have to watch out. 5 is not included. It stays open circle. The top part could be 0 all day long. The bottom part cannot. So here we go. That breaks our number line into 1, 2, 3 spots. So let's work on it. In the first spot over here, let's see if anything's working. I'm going to pick the easiest number in this yellow region, which is 0. If I put 0 in right here and right here, I would end up with a positive 20 over a negative 5. I would end up, if I plug 0 in, I would get a positive 20 over a negative 5. A positive divided by a negative is a negative, and that is not what I want. I want something that's greater than or equal to 0. So let's go to the middle. How about I pick the number 6? 6 would be between 5 and 10. And if I plug 6 in, oh, check that out. I just made it into a 6. I'd get negative 12 plus 20. That's a positive. 6 minus 5 on the bottom is a positive. So I'd get, oh, in this zone here, I'd get a positive divided by a positive. That's a positive thing. So all this stuff in the middle is valid. This is okay stuff. So what about the outside here? What about me? Don't just assume it's not going to work, because you never know with rational stuff. So let's plug something in. How about we plug in the number 20? The positive 20 would be over here on this side. And if I plugged in 20 for x, I'd get negative 2 times 20 is negative 40, plus 20 more is negative. So over here, if I plug it, I'd get a negative divided by a 20 minus 5 is 15. 15 would be positive. So guess what? Oh, it turns out this is not good stuff here. So the only answers I would get are the numbers between 5 and 10. So here's my number line. Here's 0. Here's 5. Here's 10. But remember, this one is still an open circle. That one is still a closed circle. It'd be the information between them. That would be a number line solution. In the bottom, you can never have 0. So that's why rational stuff has some weird, wacky, wild things that can happen to it. And if I wanted to in interval notation, just remember, open circles are parentheses, closed circles are brackets. So just in case you're curious, this would be interval notation, correct. This would be a number line sketch like they're asking us to do. So if you want, you can always rewind anything I'm doing here, but that's why I said this one that they gave us to do is a little bit beefy. Okay? If I'm going to do something like this, the first step is get everybody on one side, so I'd have to do that. There's my 0. But this time, look, if I want to get a common denominator for this thing, it's a little bit of this guy and it's a little bit of that guy. See, common denominator, this guy's a binomial. He would need this. So that means this guy gets this. And this guy needs this. So that means this guy gets this. And then we still have to clean up the numerator. So we'd have what? We'd have 4x minus 3 times this. So what does that turn out to look like? Well, I'll keep it red. 4x minus 3x plus 6. So what would the top part of my problem look like? It would look like this. X plus 6. Just let that sink in for a second. That is what we're going to have to evaluate now. That is what we're going to have to evaluate. So we have a critical value right here at negative 6. We have a critical value right here at positive 2. And remember, if you have a single letter involved, that means you have a critical value at 0. Now, since this is the symbol they used, everybody's an open circle here. It's true. But guess what? Now I have 1, 2, 3, 4 regions that I would have to check to see where the solution lies. And it could be maybe all of these work, or it could be maybe 2 of them or 3 of them. You know, you don't know until you start plugging stuff in to check it. But this is why I wanted to do an example like this, because when you look at the question they put on the calc packet here, this one's going to be like that. This one's going to be a little beefy. Now, the other thing you might want to consider is this. If I'm going to do problem number 20, which I'm not, I could either move this stuff over to that side, or I could do it vice versa. I could move this stuff over to that side. As long as everything's on one side, 0's on the other, you're okay. But I'm just trying to give you a heads up. Let me get rid of all those marks I just made there, because I don't want to mess you up. Okay, so guess what? Sometimes, whoops, I took away one of my marks. We have 4 regions. Sometimes we have 5 regions or 6 regions to evaluate. So I'm just going to do a couple of them with you, and then you guys can just do it. So this would be, I'm going to pick a number down here like negative 10. So if this was a negative 10, that was a negative 10, that's a negative 10. On the top, negative 10 plus 6, that would be a negative 4. On the bottom, I'd have a negative 10 times, what would this be? Negative 12. Well, that would be just a positive thing then, because I'd have a negative times a negative. Is that valid for what we want? Do we want a negative out of this thing? And the answer is, yes, we do. So this stuff right here, that stuff's good. That's okay. That passed the test. How about something in this zone here, like negative 3? Negative 3 is a number between negative 6 and 0. So once again, if I go up here and I plug in negative 3, what happens in the entire top part of my fraction? Negative 3 plus 6 is positive. And then down below, negative 3 times, well, negative 3 minus 2 more is negative 5. That would be a positive. Wait, a positive divided by a positive is not what we want. So I would say that stuff's not valid, etc. So I have to check here, I have to check here, and whatever turns out to be my answer, that's what I will color in on my number line. Woo, that's a long way to go to get there, but guess what? Now you can do this one question correctly. Okay, good luck. And don't forget, there's an answer key attached to the calc packet, so you can definitely check and see if you sketched the correct solution on the real number line. Okay, bye-bye.